Alright, back to linear functions. Slope, part 2. A line segment is shown, or segment, because it has endpoints. Okay, so in this case, not a line has arrows. The dependent variable is y. Oops. I think I need to get my pen up here. The independent variable is x. The rise is the change in the dependent variable, which is the change in y. This change is denoted by delta y. Use the graph to find the rise. So remember, we start at the left endpoint. We go 1. Okay, so we can draw this in, I guess. So we go 1, 2, 3, 4. So up 4. The run is the change in the independent variable, which is the change in x. This change is denoted by delta x. Use the graph to find the run. So leaving off here, we then go 1, 2, 3, 4, 5, which is 5. Our runs are always going to be positive because we're always going to go from left to right. So we have the rise and the run. So rise, 4, run, 5. State the coordinates of the endpoints. So A is at 3, 2, and B is at 8, 6. So 3, 2, 8, 6. Using only the coordinates of the endpoints and not the graph, how can you calculate the rise? Well, the rise is 4. The rise is the change in y values. So we could take 6 minus 2 to get 4. The run is the x values, the change in x values. And the run is 5. And we know that 8 minus 3 is 5. For the points P1 at x1, y1, and P2, or P sub 2, at x2, y2, write an expression for the rise. So the rise is the change in y, which is y2 minus y1. And the run is the change in x, which is x2 minus x1. That means we can write slope, which we know is rise over run. And the rise is the change in y, or delta y, over delta x. And the change in y is y2 minus y1. And the change in x is x2 minus x1. So the formula for slope, which will be on the formula sheet, is m is equal to y2 minus y1 over x2 minus x1. So now we have a formula for slope that deals simply with the coordinates on the plane and not us having to go and count stuff out on a grid. So we can generalize what we're doing. Use your slope formula to determine the slope of the line passing through E and F. Now, what I'm going to do is just sort of sketch these very roughly. -3, 6 and 5, 2. And see, I can see from that this line has a negative slope. So I'm going to expect that my formula, m equals y2 minus y1. And remember, it's always formula, then substitution. y2. So, well, we're going to go with this, right? So we're calling this x1, y1. And this is my second point. So it's x2, y2. So y2 is 2 minus y1. We're just substituting, right? Formula, substitution. x2 is 5 minus -3. So m is 2 minus 6 is -4. That's 5 plus 3 over 8, which is -1/2. Use the same coordinates to show the order in which you subtract the coordinates doesn't matter. So in this case now, this becomes x2, y2, and this point becomes x1, y1. And so, where do we start? With the formula. And so y2 is now 6, and y1 is 2, and x2 is now negative 3, and x1 is 5. Let's go up here. 6 minus 2 is 4, negative 3 minus 5 is negative 8, and m is negative 1/2. So, really, if you think about slope, this says go down 4, right 8. Go down 4, right 8. This says go up 4, left 8. Go up 4, and left 8. And our negative slope matches what we see from the imagined sketch, right? But we're no longer doing the counting, we're now doing the calculating. Use the slope formula to determine the slope of the line that passes through each pair of points. Okay, again, I just want to get an idea. So negative 2, 7 is going to be like somewhere here, and 6, negative 4 is there. I expect a negative slope. We know it doesn't matter what order we go in. I'm generally going to say that the leftmost point is 1.1 and this is 0.2. So negative 4 minus 7, okay, remember it's the y values, over 6 minus negative 2. So negative 11 over positive 8. 6 minus negative 2 is 6 plus 2, which is 8. 3, negative 5, 8, 10. I think we're looking at a positive line here. Okay, so we have a formula for slope. You're going to find this on your formula sheet. You're going to write it out every time you do something. Take our y values, 10 minus negative 5 over 8 minus 3. 10 minus negative 5 is 15. 8 minus 3 is 5. So the slope technically is 3. And I'll often just write that as 3 over 1 because I like to see a rise and a run. 9, 6, 5, negative 4 looks like a positive slope. And I'm really just using this as sort of a check. That is, when I work this out and I get a positive value, I won't be surprised. So negative 4 minus 6. 5 minus 9, negative 10 over negative 4, which is positive 5 halves. Okay, reducing and a negative over a negative is a positive. Wait a sec, these two guys are the same, so what's that going to look like? Negative 3, 7, negative 3, negative 8. That's a vertical line. This slope should be undefined. Well, let's see if the numbers do it the same as just, our graphical notation. So negative 8 minus 7 over negative 3 minus negative 3 is negative 15 over 0. So the slope is undefined. Here, what do we have? 2, negative 7, 7, negative 7. That's a horizontal line. So again, does the formula match with our, I want to say geographic, but that's not geographic, geometric interpretation of slope? Okay, y2, so we've got negative 7 minus negative 7 over 7 minus 2. Negative 7 plus 7 is 0 over 5, and so the slope is 0. So if the slope of a line is undefined, we know it is a vertical line. in which the x coordinates are the same. That gives you this vertical line. If the slope of a line is 0, it's a horizontal line. Right, and also remember that means delta x is 0, and we're trying to divide by 0, and that's undefined. In a horizontal line, the y coordinates are the same. We're on a horizontal line, which means that delta y is 0, and slope is 0. Recall that if p, q, and r are collinear, that means lie on the same line, then the slope of PQ is the same as the slope of QR is the same as the slope of PR. Use this to determine whether or not the following points are collinear. Note that you only have to show that 2 of the slopes are equal. Alright, so we could do like, here we're transposing, right? I mean, if PQ, this would be DE, and then EF, and then DF. So the slope of DE is equal to y2 minus y1 over x2 minus x1. The slope of DE is equal to, so we're going 2 minus 4 over 0 minus negative 4 so that's negative 2 over positive 4. So that's negative 1/2. Now, if any one of these other two slopes, DF is negative 1/2 or EF, so let's do EF. y2 minus y1 over x2 minus x1. EF, so we've got negative 1 minus 2 over 6 minus 0, which is negative 3 over 6, or negative 1/2. So the lines are collinear. Okay, so determine, and so, or sorry, the points are collinear. The points are collinear. 1L or 2Ls? 2Ls. Collinear. Okay, and what was the other slope that we could work out? Would be DF. And DF would be negative 1 minus 4 over 6 minus negative 4, which is negative 5 over 10, or negative 1/2, right? We didn't have to do that, but because it will be, if these two are negative 1/2, then this has to be negative 1/2 because the points are collinear. And let's see if example 2 is not collinear. So the slope of JK is y2 minus y1 over x2 minus x1. So 4 minus 9 over 1 minus 5. Negative 5. 1 minus 5 is negative 4. So the slope is 5/4. That's the slope of JK. Let's do the slope of JL this time. So the slope of JL is 1 minus 9 over negative 2 minus 5. That's negative 8 over negative 7, which is 8 over 7. So these are not collinear. Okay, and also, so it means any other slope. If we worked out, what do we do? JK, and that, so if we did the slope of KL, if they're not collinear, then it will be different as well. So KL would be 1 minus 4 over negative 2 minus 1, which is negative 3 over negative 3, which is 1. So all three slopes are different, which means we have points that are not in a straight line. They are not collinear. 4, 3 points. A, B, and C. Ooh, and C is some other point. We don't know exactly. We could graph A and B, but determine the slope of AB. Okay, so slope of AB is y2 minus y1 over x2 minus x1 is -3 minus -4 over 5 minus 2. So the slope of AB, that's -3 plus 4, which is 1, and 5 minus 2 is 3. So that's 1/3. Right, an expression for the slope. Now we can't determine the slope of BC because we don't know this value, but we can write an expression for the slope of BC. Okay, y2 minus y1, x2 minus x1. The slope of BC is 1 minus -3 over x minus 5. So an expression for the slope of BC is 1 plus 3, which is 4 over x minus 5. Now, what if we told you that A, B, and C are collinear? What can you say about the slopes of AB and the slopes of BC? Well, they have to be the same. So use your results from part A. We better scroll. Oops. Scroll that back up a little. So if these slopes are the same, MAB is equal to MBC, MBC. The slope of AB is 1/3. The slope of BC is 4 over x minus 5. We can cross multiply these, getting x minus 5 times 1 is 4 times 3. Or x minus 5 is equal to 12, so x is equal to 17. So if x is 17, then these points are going to lie in a straight line. Okay, and you could sort of verify these if you wanted to graph these out, and that you could find out that that would be true. It seems that that's a long ways away, but you know, that's the way it works. Determine the value of y if these are collinear points. Okay, so really what we're doing is what we just did, right? We'll work out the slope of DE because we can. If we can get a grip on our pen here. So the slope of DE, y2 minus y1, x2 minus x1. So 0 minus 4. 6 minus -2, -4 over 8, or -1/2. That's a half, -1/2. Then we know that the slope of DF or EF, I'm going to use EF because I think that's easier, so we'll get an expression for the slope of EF. You know, when you've written down the slope formula 100 times, you're going to know it pretty well. So y minus 0 over 8 minus 6. So the slope of EF is y over 2. So we know that the slope of DE is equal to the slope of EF if the points are collinear, which means -1/2 is y over 2. And so we can see the only way these are going to be equal is if y is equal to -1. And the math behind that would be -1 times 2 is equal to 2y, so y is equal to -1, and that's the value of y. Determine the missing value if the line segment joining the given points has the indicated slope. Okay, so slope of AB is where the formula comes in, right? That's why we've written it down 150 times to this point. This time we know slope, so we're going to substitute 1/2 is equal to, and we'll go 6 minus 2 over x minus negative 1. So 1/2 is equal to 4 over x plus 1. We're going to cross multiply. X plus 1 times 1 is equal to 4 times 2. So x plus 1 is equal to 8. So x is equal to 7. The slope of GH, MGH, is equal to y2 minus y1 over x2 minus x1. Substitute negative 2/3. You know, I'm going to leave that for just half a sec. So we'll do this first. So it's 4 minus 0 over negative 2 minus x. And I'm going to say, you know what, that's all going to be negative stuff. So when I write negative 2/3, I have to put the negative somewhere. I can't just leave it out front anymore. So I need to put the negative either on the top or the bottom. If I'm going to be cross multiplying and I see that my x value is negative, then I can make it positive by putting the negative value up top. So we get negative 2 times negative 2 minus x is equal to 3 times 4. So that gives me 4 plus 2x equals 12. 2x is 8 and x is 4. Moving along, m of qr is equal to y2 minus y1, x2 minus x1. Now I'm going to do things a little different order because, you know, it's nice if I have my variable first. So if we go y minus 6, I make this y2 and this y1. We'll get y minus 6, nicer expression, easier to solve, and we'll get 0 minus 4. And, oh wait, we know that slope is 2, so let's get rid of this. We want to write 2. Oops, still have the eraser. And I'm going to write that as 2 over 1. So take a slope of 2 and just write it as 2 over 1. This gives me 2 times negative 4 is equal to 1 times y minus 6. Negative 8 is y minus 6. Add 6 to both sides, and we get y is equal to negative 2. Okay, so again, what we're doing, we're using the slope formula this time, and we're doing a little bit of manipulation here to decide, right? Like, what order do I want to do this? Maybe this would have been better to go x minus negative 2. Had I done that, let's just do that here. So let's say that I had decided I want to go x minus negative 2. That's on the bottom. So I'm going to go 0 minus 4 and x minus negative 2. Then what would I have written? I've got to give myself some space here. Then here I want to write, instead of negative 2 over 3, my x will be positive. I'm going to write 2 over negative 3. So that gives me 2. This is x plus 2. And negative 3 times negative 4. So 2x plus 4 is equal to 12. And, you know, solve, and away we go. Okay, so it's how you're going to arrange this, what you have to decide. A line segment with a slope of negative 1/2 has one endpoint at 0, 4. If the other endpoint is on the x-axis, determine its coordinates by graphing. Okay, so the slope is negative 1/2. That's negative 1 over 2, or 1 over negative 2. So I want to go to the x-axis, and the slope is negative, which means I need to go down. So I'm going to go down 1, write 2, down 1, write 2, down 1, write 2, down 1, write 2, and there we are. So the x-coordinate would be 0, or sorry, 8. 8, and the y-coordinate is 0. Using the slope formula. Okay, so let's say we call this A. So we've got point A, which is at 0, 4. We've got point B. Now, since the B is on the x-axis, then we know that it has points x, comma, 0. And we're now just going to do what we've done up above, the slope of AB. So we're using some knowledge of what does this thing look like, and what does it mean when it has a point on the x-axis. It means the y-coordinate is 0. So formula, y2 minus y1, x2 minus x1. We know the slope is negative. I'm going to hold off where I put my negative. So we're going to go 0 minus 4 over x minus 0. This top expression will be negative. So I'm going to go 1 over negative 2. Right? That way I'll be multiplying, make a positive. And here I have a positive x. So we get x is equal to, right, 1 times x minus 0. X is equal to 8. And we're all solved there. Algebraically determine the slope of a line that has an x-intercept of 4 and a y-intercept of negative 6. X-intercept of 4, so this is the point 4, 0, and a y-intercept of negative 6. This is 0, negative 6. And we want to algebraically determine the slope. Well, okay, very easy to do, really. We've got our 2 points going left to right. Let's call that A and call that B. So the slope of AB is y2 minus y1 over x2 minus x1. This idea is going to come in. You're going to see this a lot in math, where we just give you an x-intercept of 4, and you have to say, oh, well, that means that there is a point at 4, 0 where the line will intersect the x-axis. And the same thing, a y-intercept of negative 6 means there's a corresponding point. So when we say intercepts, we're only ever giving a number. There's just a value. An x and a y-intercept is a value, but it's associated with a point which has this y-coordinate or this x-coordinate. Okay, slope of AB is, so what are we going to do? AB, so I'm going to go 0 minus negative 6 over 4 minus 0. So the slope of AB is 6 over 4, which is 3 over 2. So slope AB is 3 halves, right? And we know this is a positive slope. We can see from the line that it goes up to the right. And blank page, meaning this is done. So let me get rid of that blank page. I don't want that. And we're done.